Okay, so this lesson is over powers and exponents. At the top of the study guide that I gave you, Study Guide 2.9, it gives you an explanation of exponents. Expressions containing repeated factors can be written using exponents and gives you a couple of good examples. 7 times 7 times 7 times 7 times 7. What you have is a factor of 7 that's being multiplied by itself 5 times. So that's the same thing as 7 to the 5th power. It doesn't matter what the factor is. The factor could be variables. P times P times P times Q times Q. Written exponentially, that would be P to the 3rd power times Q to the 2nd power, because I have three factors of P and 2 factors of Q. Okay? Now, I want to look down at the next box, which talks about, let's see if I can get it on the screen good. It talks about an exponent of 0. It says any non-zero number to the 0 power is equal to 1. Here's what that means. That means 2 to the 0 power is equal to 1, 3 to the 0 power is equal to 1, and so forth. 4 to the 0 power is equal to 1. Anything to the 0 power is equal to 1. Now I'm going to explain that in just a minute. It also goes on to say that any non-zero number to the negative n power is the multiplicative inverse of the nth power. Now here's what that means. That means, for example, if you have 1 to the negative 2, that equals 1 over 1 squared, which would equal 1. Let me do a different one. Let's do, running out of room here. Let's do 2 to the negative 2. That would equal 1 over 2 squared, which equals 1 over 4. Is that coming on the screen? Yes. Let me explain this using patterns, because it doesn't seem very intuitive, really, that anything to the 0 power is equal to 1. So what I want to do is start with something that we know pretty simply. Let's start with 2 to the 4th power. Okay, 2 to the 4th power is 2 times 2 times 2 times 2. And that equals 4 times 4, which is 16. Okay? Let's keep going down. 2 to the 3rd power, right, equals 2 times 2 times 2, which equals 4 times 2, which equals 8. Let's keep going down. 2 to the 2nd power equals 2 times 2, which equals 4. Now what I'm wanting you to see is over here. What's happening over here? There's a pattern that's going on over here. 2 to the 1st power just equals 2, right? What's happening over here? It keeps dividing by what? Divided by 2, right? 8 divided by 2 equals 4. 4 divided by 2 equals 2. So if we kept this pattern going, 2 to the 0 power, if you keep the pattern going, well, 2, right, divided by 2 equals what? It equals 1. Whoops. Do you see the pattern? Just keep going down. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1, such that 2 to the 0 power is equal to 1. Let's keep it going, though. Let's keep the pattern going. What would be next? It would be 2 to the next exponent would be negative 1. Well, what's 1 divided by 2? It's 1/2, right? Right? 1 divided by 2. The next exponent would be 2 to the negative 2. What's 1/2 divided by 2? it's 1/4, right? And 2 squared is 4. 2 to the negative 3. What's 1/4 divided by 2? It's 1/8, which is 2 to the 3rd power. Do you see how when we get to the negative numbers, all we're doing is putting a 1 over whatever this is equal to? Okay, let's try it with a base of 3 and just see if the pattern works there. We'll start with 3 to the 3rd power. That's 3 times 3 times 3. Where is it? There it is. 3 to the 3rd power. 3 times 3 times 3. That is equal to 27. Let's keep going down. 3 squared, that's equal to 9. So what are we doing over here? We are dividing by 3. So 3 to the 1st power, if we follow the pattern, would have to be 9 divided by 3 is 3. Follow the pattern, 3 to the 0 power, 3 divided by 3, still 1. Anything to the 0 power is going to be equal to 1. Okay? Keep the pattern going. 3 to the negative 1. 1 divided by 3 is 1/3. See, our bottom number is just 3 to the 1st power. 3 to the negative 2. It's going to be 1/9. 3 squared is 9. Okay? That's what your study guide is talking about. And the reason that anything to the 0 power is always equal to 1 is simply due to patterns. And that's the reason that our negative exponents is always equal to 1 over whatever that number is to the positive exponent. Okay? I don't care what y'all say, that's cool. I know I'm a math nerd, but that is cool. All right, so let's go back to the study guide. Here we go. Let's do a little practice. Write each expression using exponents. Notice that the directions say to just rewrite the expression. It does not say to solve. Okay, so they're not asking you in these problems up here to figure out what it's equal to. They're just saying rewrite the problem in a different way. They want you to rewrite it using exponents. So what you do, you have factors of 8, right? 1, 2, 3, 4, and you have 5 of them. So rewritten, that would simply be 8 to the 5th power. Easy breezy lemon squeezy, right? Okay, look at number 2. You have a factor of 4, that's your base, and you have 1, 2, 3, 4 of them, 4 to the 4th power. Okay, you can do the same thing even if your factors are variables, that doesn't matter. Your base here would be A, that's your factor. How many factors do you have? 1, 2, 3, 4, 5, 6. Okay? Number 4. Get all of it in there. You've got a factor of G. And you have 1, 2, 3, 4, 5, 6, 7 of them. Okay? 5 and 6, you guys are going to do that on your own and bring it to class. Okay? Now move on down to where it says evaluate. Alright, now when it asks you to evaluate, that looks blurry. There we go. That's still blurry. And I don't know how to fix it. Okay. When it asks you to evaluate, it's asking you to solve. Okay, so you're going to have to actually do the math and figure out what it's equal to. 4 squared, that's the same thing as 4 times 4, so that's equal to 16. Okay? Number 8, 5 to the 3rd power. That's the same thing as 5 times 5 times 5, so that's 25 times 5. I believe that's 125. Okay? I'm going to skip down here to these negative ones. Look at number 11. It says 8 to the negative 2. I know it's going to be a fraction. It's going to be 1 over 8 squared, which is equal to 1 over 8 times 8 is 64. Okay, that's all that negative exponent means. It doesn't indicate a negative number, just like when we were working with scientific notation. The negative exponent did not indicate a negative number. It simply indicated that your number was going to be getting smaller, not bigger. All right? I'll tell you what, the rest of the problems you can do and bring into class tomorrow, 9, 10, 12, 13, and 14. All right? I think that'll do it for this lesson. I will see you tomorrow.